Welcome to ZS Circuits Electronic Systems. This is a demonstration of the IoT Power Profiler tool, ZS2102A. This tool can be used to accurately estimate the battery life of IoT devices. Estimating the battery life requires accurate measurement of the current profile, as well as an accurate model of the battery used. The IoT Power Profiler tool is custom made to do just that. In this demo, we measure the power profile of a popular Wi-Fi module and estimate its battery life. The Wi-Fi module is powered by two AA batteries, and it is programmed to connect to an access point, send some packets and then go to sleep mode. It then repeats the cycle over and over. A typical IoT application profile, but the sleep time is reduced for the demo. We connect the Power Profiler tool to the PC using a USB cable. Then we connect the Wi-Fi module and the Power Profiler in series with the battery. We open the software and connect to the tool using the Connect button. It asks to perform a calibration, which is initiated by clicking on the Calibrate button. We disconnect the load and follow the on-screen instructions. The tool performs a calibration which takes about 15 seconds. During the calibration cycles, the GUI estimates the offsets, gain errors, and the noise variance within the tool for later correction. It is important to perform calibration before each long measurement, and every USB connection of the tool. This improves the overall accuracy of the tool. Let us wait for the calibration cycle to get over. The calibration is now completed, and the tool is set for capture. We connect the load in series with the profiler and start the measurement by clicking on the Start button. We create a new profile for the measurement cycle and the tool starts the measurement. Several spikes are observed on the current profile as the module connects to an access point. These are transmission cycles which we will analyze later in detail. Let us wait for the tool to acquire multiple cycles for a better estimate. It continuously samples the current and voltage to provide an accurate estimate of the power consumption. The tool sends about 64 megabits of data per second over the USB bus to the GUI software. Using state-of-the-art compression method, the final bit rate is reduced by almost 100x. Storing compressed data allows the tool to record profiles longer than 10 hours at a stretch. The samples are stored directly on the hard disk, and the real-time current is indicated by the graph and the dial. There is also a digital readout for the voltage and the average current. Let us wait for the tool to collect multiple cycles of data. After about 5 minutes, we stop the capture by clicking on the Stop button. The top chart shows a 5-second span and the middle chart shows a 100 millisecond window. The bottom chart shows an 8-bit digital signal which is connected to the Power Profiler. This can be used for synchronization of current data with firmware signals. We can use the slider to move across the time span. We can zoom in and zoom out using the scroll wheel on the mouse on both the charts. The red curve indicates the battery voltage and the green curve shows the current drawn over time. We use the slider to move across time and we make some interesting observations. The device is in the sleep state for a long duration and it then wakes up on an internal timer. We see some strange current spikes after the device comes out of sleep mode. Let us analyze those spikes by zooming in. We zoom into that area using the mouse selection on the top chart. On zooming in, we observe the current ramps going from 100 to about 350 milliamps. This is some calibration of the internal power amplifier on the module. The power amplifier is cycled through different power levels, across multiple channels. The tool clearly gives fine details about the current drawn by the module. We slide forward and find some pulses in the waveform. Let us analyze one pulse in detail. We scan for that pulse and try to center it on the screen. We select the desired span using the mouse selection for quick analysis. It consumes on an average about 330 milliamps and it is about 550 microseconds wide. By further zooming in, we can measure the rise time of this pulse to be about 14 microseconds. This shows the response time of the tool. The tool can in fact respond to pulses within 2 microseconds. We skip forward and find some receive state of the module with some digital activity. It consumes about 67 milliamps in this state. We keep moving ahead and make other observations. Further ahead in time, we find that at about 65 seconds, the module enters the sleep state again, and the current goes down to few microamps. We select that span and we measure about 15 microamps of sleep current. The tool spans a dynamic range from few microamps to several hundred milliamps without range switching. Finally, we use the estimation box to estimate the overall battery life with this profile. In this case we select the battery as MN1500 made by Duracell. The tool analyzes the current profile in conjunction with the battery model, for better estimation. We calculate the battery life of about 4 days, with a 1500 mAh battery. Let us select another battery which is the CR2477 which has a capacity of 1000 mAh. We expect a battery life of about 2.6 days by simple calculations. But the tool estimates the battery life of less than 1 day with this. This is due to the lower peak current supported by the battery and faster capacity degradation with higher currents. The tool thus estimates a more realistic battery life based on real-world data rather than just the mAh number. Let us study some more features of the tool. The GUI allows comparison of 2 current waveforms at a time which can be used to compare different firmware or hardware changes on the IoT devices. The plots are synchronized with each other using a pulse on the digital I/O input. The waveforms can be aligned in time using this pulse. It also features trigger search on both the digital input as well as the current data. We can also create custom battery models based on manufacturer's data, or experimental results. The models can be later retrieved for battery life estimation. This enables the user to select the right battery type and capacity for the application. The data can be exported to an XML format using the button below the middle chart. The length is limited to 1 second due to large size of ASCII data. The tool also supports exporting the captured data to a SIGROC format. This can be later viewed on Pulse View software for protocol analysis. Summarizing the performance of the tool, we observe that it can measure currents from few microamps to hundreds of milliamps using a single measurement range. The tool uses a precision 0.1 ohm resistor for all measurements. There is no relay switching and load tripping associated with switched shunts. The accuracy is 1% of the measured value or 1 microamp. The maximum voltage drop due to the Power Profiler tool is well within 100 mV at all times. It can respond to pulses which are few microseconds wide, and measure them accurate to 1 microsecond. The digital I/O port can capture 8 bits of data sampled at 1 megasamples per second. This digital data is synchronized to the current measurements. There is an SMA connector at the back panel, which gives out the 1 MHz internal clock to be used with external systems for sync. The Power Profiler can store the data directly to the hard disk, and there is almost no capture length limitation. Data capture spanning 24 hours is easily possible with the ZS2102A. The current profile, which can be measured by this tool, cannot be performed by any multimeter or an oscilloscope. Most multimeters cannot respond to fast pulses, and oscilloscopes do not have the required dynamic range, and have memory length limitations. These can be very expensive to buy, and bulky for mass deployment. The ZS2102A comes in a compact USB-powered solution, with a nifty software and technical support. ZS Circuits offers a 12-month warranty on the product with a 1 month of no questions asked free returns. Order your Power Profiler at our store, anglercircuits.com. Exciting early bird offers available. We thank you for your interest in the IoT Power Profiler tool.